Test, 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 test. Good evening, ladies and gentlemen. Thank you for joining us here at the Ontario Science Centre on this lovely Wednesday evening. This is your, at this point, 3.5-minute warning. Please make sure that all your devices are off or on mute or airport mode or whatever it's going to take to make sure this thing does not ring during the presentation. If it goes off, you're buying. A couple of housekeeping issues. Please do not use these doors during the presentation. You have to exit, use the washrooms. These go out the back, and washrooms are around and down this way. Thank you very much.
Hello, everyone, and welcome to the April Recreational Astronomy Night meeting of the RASC Toronto Centre. My name is Paul Markov. I'll be your host for this evening and introducing the speakers. We are at the Ontario Science Centre in front of a live audience of about 20 people. For our online viewers, please join us in person next time if you can make it. And for those who are here tonight, thank you for braving the rainy and windy weather. Not very nice out there tonight. Now, for those who definitely cannot join us in the future, rest assured that the live broadcasts will continue. Thanks to our awesome AV team that's made up of Andrew and Betty Reed, and Ward Legros and Ennio Cellucci. And at times we have other members who also assist with setting up this online show. In regards to upcoming meetings, our next meeting is May 1st. The Recreational Astronomy Night meeting is on May 1st. And this time around, I specifically did not coordinate any presentations. It's wide open, and the reason is I'm expecting people to come forward with solar eclipse presentations. So I'm gonna wait, see what happens after Monday for people to approach me who want to present. And if we have a lot of people wanting to present, there's a good chance we're going to skip the Sky This Month presentation that we typically do, so that there's more time for solar eclipse presentations. It'll be first come, first serve, and in the event that there are a lot of people who want to present, those eclipse presentations may spill into the June meeting as well. All right, so before we proceed with the lineup for this evening, I wanted to read you a quick email that came in this afternoon in regards to the solar eclipse and weather from one of our members, Frank Dempsey. Frank is an active Toronto Centre member. He's given several talks, but he's also works for Weather Canada. He's a weather forecaster. So we trust him a lot in what he tells us. And he wrote here that although the computer forecast model predicted a high pressure recently, like as late as yesterday, over southern Ontario, a new development is a low pressure storm, which is forecast to develop over the western US and then move eastward to the western Great Lake region on Monday. So total change from yesterday. Yesterday was nothing but sunshine. Now we've got this low front developing in west of us. So this is going to cause cloudiness to spread over southern Ontario ahead of a warm front associated with the low pressure. So how much cloud and how far eastward over southern Ontario can be accurately estimated yet, since the low does not exist yet. We ought to get a better idea after the low develops and strengthens over the central US during Saturday. So one consequence is that Monday's high pressure ridge and region with clear skies east of the ridge is likely to get moved eastward from southern Ontario. So in fact, if you look at the weather for London, Ontario now, for Monday, they're predicting rain. Toronto, Niagara Falls, cloudy. Belleville, a mix of sun and cloud. Further eastward, I didn't look, but probably clear. So as usual, the clouds are coming in from the west. So fingers crossed that this low pressure is slow, stays away, and it doesn't engulf all of Ontario all the way to Quebec, right? All right, so that's the latest that we have. Now, speakers for this evening are Andy Beaton will present the Sky This Month, followed by Joel Dick, and he'll talk to us about Jewish astronomy and the Hebrew calendar. And then we have Ralph Chou, who will tell us about the EC Carr Astronomical Observatory, which is the Toronto Centre's own observatory up on Blue Mountain. And then we'll have Tom Luton, our president, close the meeting with announcements, and we should be done around 9:30. If you're watching us online and have a question, please enter it in the chat box, and Ennio will ask the question on your behalf to the speaker. And in the room, if you have a question, put your hands up and I'll come over to you with a microphone. So you speak into the microphone and people online can hear your question as well. Do we have anybody here for the first time, whether you're a member or not? Just wondering. We have 3, 4 people. Welcome. Very good. Hope you enjoy the presentations. And also, if you're watching us online for the first time, please let us know through the chat box as well. So let's get the meeting started with Andy and the sky this month.
Hi, hello. My name's Andy Beaton. I observe the horribly polluted skies of downtown Toronto, and once again, I'm here to talk about the sky this month. People who have heard me talk before will probably recognize most of this list. The big picture, key dates coming up. This time, I've thrown in a little bit on the eclipse. Then we have the moon, the planets, something in the deep sky. I always like to throw in a double star, and it wouldn't be my presentation if we didn't talk about a variable star, and then whatever's coming up in the world of spaceflight over the next month. So starting off with the big picture, tonight around 9:30, if we could look through the clouds, this is what we'd be seeing. Our favorite winter constellations are sinking into the west just after twilight. Taurus is just above the horizon, Orion and Gemini following behind. You may notice that whatever planets we get, we've got Jupiter and Uranus there just above the horizon, and that's about all we're seeing there in the sky tonight for planets. A month from now, we get up at 4:30 in the morning, just before twilight starts. We do get to see some more planets. We get to see our favorite summer constellations coming up. We've got Scorpius and Sagittarius there, and the Summer Triangle, and even Pegasus showing up just on the horizon. And we've got a few planets coming in the morning. If you're a keen planetary observer, this will be the best time of the month. So important dates coming up. April 8th is obviously the one everybody's watching for. It's also the date of the new moon. So once you're finished looking at the eclipse, you can set up your telescope and do some good dark sky observing later. The moon is at apogee on April 20th and perigee on April 7th. I always like to encourage people to take pictures of the moon at those two times and compare the two images so you can see how the further and closer distances are reflected by the size they appears in the sky. Full moon is on April 23rd, and on April 22nd we have the Lyrid meteor shower. So April 8th, I've thrown in an extra, this is what the sky is going to look like, and it is, you can see the moon is being highlighted there since you can't see the sun. And we can also see a bunch of planets. In theory, we should be able to see all the planets, assuming that the sky gets dark enough. We also should be able to see a bunch of the winter constellations showing up around there. It'd be an interesting scientific experiment to see how bright stars you can see and how close they are to the eclipsed sun. So we've thrown in a map here of where the path of the eclipse is going. You can see it's just passing through our neighborhood in the later part of the eclipse. So we are not getting the maximum length of the eclipse. That's happening down in Mexico. But here we have the path of the eclipse in our neighborhood. As we can see, if you live in Toronto or Ottawa, you're out of luck. If you're in Montreal, you're better off. Otherwise, you're probably going to have to travel. I will throw in the warning I've been giving to everybody I've been talking to for the past 3 months. If you need to travel, get there early because traffic is going to be a nightmare. Assuming you're in Niagara Falls, that's the closest place that I think most people in Toronto are going to try and get to. The partial eclipse starts at 4 after 2 daylight savings time. Total begins at 3:18, and goes to 3:21, and the partial one ends around 4:30. So times for Toronto will be similar. So if you're planning to at least look out the window and see what's happening, this is a rough idea of what times you should be thinking of. So this is the time of year. Nights are getting shorter. Astronomical twilight's ending at 9:15 tonight, starts again at 4:55 in the morning. By the next meeting, astronomical twilight will be ending at around 10 and starting again at 3:50 in the morning. This is all daylight savings time. So if you're doing your long-term imaging, be prepared to be inconvenienced by the sun. We have the moon phases, first quarter on the 15th, April 32nd. But one day I'm going to have one of these things and it's not going to have a typo in it. That's April 22nd. Thank you very much. Last quarter on May 1st and the new moon on April 8th. Obviously, the new moon is causing the eclipse. Something to note is it's also one day off the moon's closest approach. So this is going to be one of the longest eclipses we get because the moon is going to be just about as large as it gets, kind of an anti-supermoon. The next lunar X, April 15th, starting around 11:50 in the evening. For those who don't know, the lunar X is a feature on the moon. It's two craters side by side, and at a certain point every month, the sun hits it at just the right angle, so it looks like there's an X on the moon. Scientifically, not interesting, but it looks neat. And I like things that look neat. The lunar straight wall, Rupus Recta, is another lunar feature where when you get the sunlight coming in at a certain angle, it also looks neat. And April 17th will be the time to look for that. Planetary highlights, Mercury, Venus, and Mars. Mercury is disappearing. Late in the month, it'll show up again in the morning. Venus, we're not going to see it at all this month. It's just too close to the sun, although we might see it during the eclipse. Keep that caveat in mind. In the morning, Mars will be appearing later on in the month and getting better as the month progresses. Unlike Mercury, it improves over time and doesn't disappear again. The big showpiece planets, Saturn and Jupiter. Jupiter is low in the west at sunset, and as the month goes along, it's going to get further and further away. Saturn is low in the morning twilight, but as the month goes on, it'll rise earlier and earlier and be better suited for viewing. I wouldn't put a lot of effort into seeing either of them this month. They're never going to be very high. The atmosphere is going to mess them up. There are probably better things to see. The ice giants, same problem. It's just a lousy month for planets. Uranus is still visible in the evening, but it'll be disappearing. Neptune slowly appearing in the morning, but they're dim. They're going to be close to the sun. Once again, I wouldn't bother showing up for either of them. The dwarf planets, Pluto and Ceres. Pluto is rising in the morning. By the beginning of May, should be visible before twilight. It's getting further and further away from the Milky Way, so it should be a more interesting target, easier to find. It's always tough visual. I would recommend trying to take pictures of the area with as much time as you can manage and look for that little dot moving. Ceres is rising ahead of Pluto. It's around 8th magnitude and should be visible in binoculars. Eris, no, we're not going to try that this month. I like to throw in a bit of deep sky stuff. In the spring sky, a popular target, we have Markarian's chain, a string of galaxies on the Virgo-Coma-Berenices border. Here, that's what it looks like, more or less. 8 gravitationally linked galaxies, 4 singles, M84 and 86, NGC 4473 and 4477, and then 2 pairs of linked galaxies, the eyes and 4458 and 4461. All of them should be visible in a 4-inch scope under a reasonably dark sky. Under a downtown city sky, you might get M84 and M86, but I wouldn't want to promise anything. This is more or less what it looks like. The bright 2 in the middle are the eyes. The brighter 2 to the lower right on my screen here, lower right, are M84 and M86. If you have children to entertain, there's a small galaxy and a star that makes a face that you can show them in the telescope. Now, I know many of the people here are looking for something more challenging than a couple of galaxies. There are a lot of other faint galaxies in this region, some of them related to the group, some not. The eyes are interesting. You can see that they're distorting each other through the gravitational interaction. And with an excellent telescope and an excellent night, or even with long-term imaging, you may be able to see matter, the bridge connecting the two. The other interesting thing that comes up with M84 is elliptical galaxies tend not to have supernova, but M84 has had 3 of them in the past few decades, which is weird and unusual. If you're the kind of person who likes to check galaxies every night to see if there's a supernova there, M84 would be an interesting target because it's a puzzle why it's having so many. Let's see, comets and meteors. Starting with the meteors, we have the Lyrid shower coming up on April 22nd, 20 meteors an hour. Not bad, very close to the full moon, bad. We have a minor meteor shower of the Pi Pupids. That one is likely visible further south than here. The place it's appears to come from the sky is way below the horizon for us. Number of stars is variable. I've thrown it in there because I know for a fact that sometimes we get Southern Hemisphere observers listening in on this talk. So I hope this is of use to them. Meteor dribbles, the Alpha Virginids, the Kappa Serpentids, the H Virginids, all little tiny showers, maybe 1 or 2 an hour. Autocorrect has corrected the Serpentids to serpents for me, which I appreciate very much. I wouldn't bother looking for any of these, but if you're out and you see a meteor during any of these periods, try tracing it back and see if you've got one of these rare and obscure showers. Now, comets, obviously the big one everyone's talking about is 12P Pons-Brooks, currently reported at 4.7th magnitude in Aries, may be visible at sunset, may be visible during an eclipse. Try finding it under any possible circumstances. This is the brightest one we've had for a good long time. I have not been able to see it because of clouds and buildings around my home. I hope some of you have. We have 13P Olbers at 10th magnitude in Taurus, C2021 S3 Pan-Stars in Vulpecula. That's going to be a nice one in the morning, be right up and high in the sky. C2023 A3 Tsuchinshan, I hope I pronounced that right, Atlas, 11.2 in Virgo, and 62P Tsuchinshan, 11.4 in Virgo. So obviously, Pons-Brooks is the ones that people are going to be excited about. If you've seen it, comment on the YouTube channel. I'd be curious to know. We're still in solar cycle 25. Solar activity is on the rise. We should be seeing more sunspots and more prominences than usual. We should be seeing more aurora. friend of mine was up in Yellowknife last week and took this image with a camera phone. So this is bright. So if you get a chance to look for aurora, keep an eye out at spaceweather.com for maps and up-to-date forecasts. I want to look at that just for another second. I really like that. So double star, have to have a double star. Cor Caroli or Alpha Canis Venatici, or the first star of the Imperial Guards if you happen to be observing from China. A 2.9 and 5.6 magnitude pair, blue and green. The Observer's Handbook gives them 3 exclamation marks for being an excellent and beautiful pair. I couldn't find anything of particular scientific interest, but once again, it's nice to look at. I think we concentrate an awful lot on what is scientifically interesting, and sometimes we should just go and look at the sky and admire how beautiful it is. So we have to have a variable star. T Corona Borealis. This is a recurrent nova which went into outburst in 1946. It should be coming up sometime within this year when it goes from 10th to 2nd magnitude and turns into the brightest, if not the brightest star, one of the brightest stars in that constellation. It's one of those situations where you have a red dwarf dumping material onto, having material dumped onto it by its companion red giant. And as it turns out, it's stripping the material off in a nice consistent rate, so you get a regular, predictable outburst. This is one where it will be of intense scientific interest. Professional astronomers, however, don't have time to sit there watching it. They are counting on you and I, the amateur astronomers of the world, to keep an eye on it. If you see it, go to the American Association of Variable Star Observers website, aavso.org, and report it. That's where people will be watching to see when it happens. That will be your chance to contribute to science. And on a similar note, this one just showed up in my mailbox yesterday. SS Cygni. Dr. Mariko Kimura is asking for our assistance in monitoring that star so that they can coordinate observations with the XRISM satellite. Another one of those situations where you can't have your satellite just sit there waiting for this thing to happen. They're counting on you and I to monitor that star, and when they see it happening, report it and get that satellite pointing there to gather the data. So coming up, we have spaceflight highlights. Rocket Lab Electron launching a solar sail test on April 24th. The Boeing Starliner first crewed flight to the ISS on May 1st. April 18th until the next meeting, we have ISS morning passes. And once again, heavensabove.com for times and locations. And if it's cloudy, the Event Horizon Telescope is showing new images. This is the one that caught my eye. This is the black hole in the center of our galaxy, Sagittarius A star, in polarized light. And what that's showing us is there are intense magnetic fields around the black hole in the center of our galaxy, which is kind of interesting. And what if it's cloudy, like it's been for 6 months? Zooniverse.org is my go-to place for citizen science projects. A few I've picked this month are Backyard Worlds, looking for brown dwarfs, superluminous supernova in other galaxies, Redshift Wrangler, analyzing redshifts from distant objects, and Solar Jet Hunter. There is a Zooniverse app available for iOS and Android. I don't know about BlackBerry. So just a final note, more eclipse information. I know people are going to want this. Check this video out on YouTube so you don't have to write it down now. You can come back later and get those links. That's where I've been getting all the eclipse information I've been passing on. or type 2024 eclipse into your favorite search engine. And if you have questions, I'm happy to answer them offline. Any typos other than the obvious ones that I've already caught myself on, contact me there. And thanks very much.
We have online. One here. Okay.
So speaking of Mars, when would be the best time to image it?
Not this month. I would hang on for 3 or 4 months and wait for it to get high enough and far enough away from the sun that you're going to be able to get a decent image of it. I would wait for well into the summer, yeah.
Thank you.
Any more questions in the room? Online?
We have questions online. Good evening, everyone. So Victor O. Jung starts us off with questions with, does RESC Toronto still have deep sky star parties at Long Sault monthly? Followed by Frank Dempsey then replying with, Long Sault Conservation Area. Is it still illegal to use at night, or is the parking lot closed at dusk?
That's an excellent question. I haven't been out to Long Sault in a long time, so I don't think I have an honest answer to that. I suppose somebody could look it up, and if anybody is ever out in the Long Sault area, take a look and see if they are locking it up on us.
Thank you. So Frank Dempsey next has the remainders of comments. Frank Dempsey comments with, Comet 12P Pons Brooks is just a bright fuzzball visually, but might be interesting in the dark sky. Frank also says, KCRB is a good excuse to glance up at Corona Borealis constellation every clear night.
Yeah, actually, the cool thing about T Corona Borealis is you are going to be able to see that one with the naked eye. You don't need to haul your telescope out. You don't even need to have a pair of binoculars. You can see second magnitude stars anywhere in downtown Toronto, just about, as long as you're not right under a streetlight. So it would be an excellent project just to go out there and take a look every night while you're walking the dog or going out to buy donuts. Just have a look and see if that constellation has changed shape.
Eric Briggs comments, Dr. Chant observed a solar eclipse from Colorado, apologies if I butchered that, on June 8th, 1918, and that night there was a very bright nova called the Victory Star. What are the odds of T Corona Borealis going off on this eclipse day?
Oh, excellent question. I hope it's 100%. I would say the odds of, well, if it's going to be between now and September, we're talking about 5 months, 150 days. So I don't know, 5 days between now and then, out of 150, 1 in 30 chance, 3% chance just off the top of my head. How's that?
Awesome. And that's our questions.
Thanks very much.
So we're going to take a short break and go to fun facts while we set up the next presentation. All right, and we're back. And before we move on to our next presentation, I'd like to call on Ralph Chou, our past president, to present the RASC Gold Medal Award.
Good evening, everyone. Since 1986, the Toronto Centre has been able to present the gold medal, which recognizes scholarship in the astronomy programs offered by the University of Toronto and York University. Tonight, I'm really pleased to be able to do a personal presentation of the gold medal to the 2023 recipient from York University, Darren Singh. Darren is here with us tonight. Luckily, this is the first time we've been able to do this since COVID, and I'm really delighted that he is here. He graduated from the Bill Crothers Secondary School in Markham, Ontario, where he excelled in basketball. Following graduation, he enrolled at York University, but strangely enough, astronomy was not his first choice. In fact, as he writes, when he was in high school, I was constantly curious about how things worked. And I ultimately found it easy enough to learn about how most things, such as engines, computers, etc., worked through the internet. However, when I started to wonder about how things like the sun and more broadly stars or gravity worked, the internet did not offer me much help. I found that high school physics did begin to explain some of these things to me. Astrophysics, astronomy was never my main interest in university. My main interests were actually marine biology and automotive engineering. However, through a funny turn of events, I ended up pursuing an astrophysics degree at York University. The reason that I ended up staying in the degree is because I realized that it answered most of the questions that I had about how things in the world worked. As a student in the physics and astronomy program at York, Darren developed an interest in dark matter. He spent a summer as a research student and had the opportunity to attend a research conference in Germany. He finds it intriguing that while there is strong evidence of the existence of dark matter, we don't understand it or what it is. He's presently studying for a Master of Management in Artificial Intelligence at the Schulich School of Business at York, and he hopes to complete it this month. He then plans to become a data scientist in one of the AI machine learning industry. So congratulations on your academic achievement, Darren. I'd like you to come forward to receive the gold medal, and congratulations.
Okay, all yours. Okay. All right, so we are all set up to get Joel up here and present to us about Jewish astronomy and the Hebrew calendar. Come on up, Joel.
Thank you. All right, thank you, Paul, for the introduction. My name is Joel Dick. I've been a member of RASC for, coming on to, 8-9 years probably now. I'm as a amateur astronomer, so this talk is not going to be super technical. I tried to balance it out a little bit to make it a bit recreational, but apologies if I do get somewhat technical. How do I advance slides? Is it just the arrow? There you go. All right, so this talk is about Jewish astronomy and the Hebrew calendar. So the Jewish history is full of very famous astronomers. There's a very intimate connection between the Jewish religion, Jewish culture, and astronomy. I don't know how many people here are aware of that, but historically, a lot of famous astronomers have been Jewish. And just to illustrate that point, the craters on the moon are all named after prominent scientists, and there are several that are named after historical Jewish astronomers. And I've highlighted a few of those over here. I'm not sure how clear the image here is, but if you look at that one down at the bottom, Zagut is actually quite a, you can actually make it out on a clear night. The other ones are a little harder to see. But Aben Ezra is named after Abraham ibn Ezra. I don't know why the name was changed to Aben Ezra. He's pretty famous. There's a He's more better known as a poet, medieval poet, who lived in Spain and France and other areas. The second one is Rabbi Levi ben Gershon, who's also quite an important figure. And that third one, Zagut, is Abraham Zacuto, who actually played quite an influential role in the history of astronomy and naval exploration. So we'll get to that in a minute. All right, so let's just to give you a little bit of background on the different figures. I've skipped Ibn Ezra. He's he's the oldest on this list. I didn't have that much information about the work that he did, except just that he wrote several books about the Jewish calendar, about mathematics, about tables astronomical tables of times and dates and so on. But Levi ben Gershon is actually quite an interesting one. He was born and lived in Provence, France, and he translated, and he was very much influenced by Aristotle and Averroes, and he made even some corrections to some of the works of astronomy of Aristotle. Averroes is a famous Islamic astronomer, medieval astronomic, who was also very influential. So a lot of the distances, Ptolemy, the Ptolemaic model of the universe, of the Earth in the center with the several spheres around it, Ptolemy gives a measurement for the distance of the fixed stars, and which of course is very inaccurate in today's measures. Rabbi Levi made an update to that, which is slightly more accurate. Again, it's not accurate by any means in modern terms. But the most interesting thing about him is that he's the inventor of Jacob's staff. So until then, the main instrument that was used and you can see this is a stamp that was put out by the government of Israel a number of years ago. You can see that big ship there in the background. So the main instrument that was being used in naval navigation was the astrolabe, which is a little disc, and you turn the disc to see the height of the sun, to tell where you are in latitude. So what he came up with is actually quite a simple concept. All it is just a bar in the middle with a stick at the end, and as you move the stick further and closer away, you get a bigger and smaller angle, and there's little ticks along the middle bar that shows you degrees. So it's basically a trigonometric tool. It's sort of like a protractor almost, that tells you the angle between the horizon and any given star, and that's thanks to Levi ben Gershon. The third name actually on the list is Abraham Zacuto. He lived far later. This is 1452, so this is already 15th century. He was not in Provence, France, but he was in Spain, which is Castile and Leon. To give you a little bit of a historical background, the Jewish community of Andalusia and Spain and the Iberian Peninsula goes back very far. They flourished under the Islamic rule, and a lot of those Jewish astronomers were working for a lot of the royal courts under the Islamic rulers, and they understood Arabic. A lot of the old works of astronomy, especially, for example, Ptolemy, was translated into Arabic. We'll get to that in a minute. So a lot of that knowledge from Ptolemy was then brought over to the Christian world as Spain was reconquered by the Christian rulers. A lot of those old Jewish scholars who had translated into Arabic, the Christian scholars or the Christian kings and so on, did not understand Arabic. So a lot of that translation work then got done by the Jewish astronomers that were working in that court. So this Abraham Zacuto was a royal astronomer in the royal court under the kings of Castile and Leon. What happened in the 1470s, I believe it was, is Spain was unified. The king of Aragon it was the queen of Aragon and the king of Castile and Leon, Ferdinand and Isabella, who were famous for being the king and queen who had sponsored Christopher Columbus's voyage to America. After unifying Spain, they expelled all the Jews from Spain. So a lot of them fled to Portugal. A lot of them fled to the Netherlands or other areas in France or Germany, which had also large Jewish communities. this particular astronomer, Abraham Zacuto, he fled to Portugal, and under the king of Portugal, who was King John II, he was the royal astronomer. And actually, it was before he fled that he had actually produced tables of where various, based on the elevation of certain astronomical objects, you were able to chart exactly where you are in the world, at least on in terms of latitude. Longitude is another story, which a lot of you might be familiar with. So this is just to show you the plate I show on the bottom, on the left here, is the Alphonsine tablets, which is King Alfonso of Spain. This was done much earlier in the 1270s, again, based on older translations that were done throughout the medieval times. Zacuto's almanac, and actually when he wrote it, it wasn't called almanac, it had a Latin name, or actually almanac is the Latin name. When he wrote it in, I guess it would have been Arabic or Hebrew. I think he called it Chibur Hagadol. It was called the Great Work, or the Great Work, I think it was called, and then it was translated later into Latin. And this was essentially the authoritative source that was used by naval explorers for including Christopher Columbus. And actually, Christopher Columbus names Zacuto in his diaries, or actually in a letter. Everybody knows the story of Christopher Columbus and the eclipse. In his accounting of it, he says that it was Zacuto who predicted that. So it was thanks to Zacuto that Christopher Columbus was able to know exactly when that eclipse was happening. All right, so let's sort of explain, where does this go back to? Where does the affinity that the Jewish culture and Jewish religion have for astronomy, where exactly does that come from? So I mentioned one factor. One factor was the fact that a lot of the Jewish scholars thrived under Islamic scholarship, which were the inheritors of the great banks of knowledge, of Greek knowledge. After the Library of Alexandria was burnt down, a lot of that stuff went to the library in Baghdad. So Ptolemy's books, those all inherited while Europe was still in the Dark Ages. So the Jews were sort of the custodians of that, and they were the go-between between the Islamic world and the Christian world. So that was one factor, that because they understood Arabic, and they also wrote a lot in Hebrew, and that's one factor. But let's see if we can trace this back. So to the Bible. All right. So in the Bible, there's not that much mention of astronomical details. But one interesting reference, which if you ever go down this rabbit hole and Google astronomy in the Bible, this is probably where you're going to end up. So this is the book of Job, and there's several astronomical objects that are mentioned. So I'm going to read it in Hebrew here. Osa ash ksil v'kima v'chadrei teman. So he makes, this is referring to God, he's the creator of ash. So ash is one astronomical object. Again, this is debated by scholars exactly what it's referring to, Ksil and Kima. And then there's a second reference in Job. And this one's more interesting because this gives a few more clues to what the identity of these objects. So hit kasher madanot Kima. This is God speaking to Job, saying, Job questions God. Job, the story of Job was, he was a guy who was given tribulations by God, and he lashes out and he says, why is God giving me all these troubles? So then God answers him and says, do you understand my ways? And the chapter 38 goes through all the different natural phenomenon that God creates in the rain and the ice and storms and all that. And in there is a reference to astronomical phenomenon. And God is sort of asking Job, are you able to understand my ways? Are you able to tie or bind the madanot, are chains of Kima, or the moshkos are the ropes of Ksil? So the translation it uses here is Orion. Ksil in Hebrew means the fool. Right? That's what Ksil is, the fool. And I always found it interesting when you look at Orion, he sort of looks like a fool, and he's got that belt, which is sort of his bind. So I think Ksil is referring to Orion, and I think most people would agree. Hatotzi Mazarot Be'ito, that's something else. Mazarot is another one. And I find when this is Ayish al B'nai Tanachim, can you console Ayish on her children? So I always tie this to the legend of the seven sisters. Right? which is sort of like the mom and the dad chasing after all their little kids. I don't know if you've ever seen a picture. I should have put a picture of the Pleiades in here. But the Pleiades, I think this might be referring to the Pleiades. And the Talmud, which is dates a little later, this is the Talmud from about I would say, written anywhere between the 2nd century and the 6th century, has a legend which it ties to the story of the flood. And I'm just going to read the passage quickly over here. It was taught in the 600th year of Noah's life. In the 2nd month, that's in the Bible, that's in Genesis. The flood started, that the fountains of the deep opened and the world started flooding. That was Noah's flood. So Rabbi Joshua says that day that the flood started was the 17th day of Iyar. Iyar is the month following the spring equinox. It's the day on which the constellation Kima, so we don't know what Kima is. Xil identified as Orion. Kima is a lot more controversial. We don't even know, is it in the southern sky? Is it in the northern sky? What happened was it sets during the day. So we're about almost coming into spring now, and Orion doesn't really set during the day. So certainly I don't think it's talking about Orion. It's probably referring to another constellation in the south. But this is somewhat controversial. And the season that the spring diminishes and increases heat. We're going into the summer. So Kima is associated with a constellation that takes out the spring and brings in the heat of the summer. So because the world changed their actions, the Holy One changed the act of creation, which means he distorted nature, and he caused the constellation of Kima to rise during the day, and he removed 2 stars from Kima. So the constellation rose at a different time of the day than it was supposed to rise, and that's what caused the flood of the world. So there you have it. This is part of the legend of Noah's flood. This is Talmudic, which is centuries later, after the Bible was written. Now, this is from a different book of the Talmud, where there's a lot of clues in here about exactly. I don't want to go too much into this because I don't want this talk to take too long. But you do have I'm going to read a little bit over here. This passage here is referring to comets. And there's a very interesting passage over here that on comets you say a certain blessing if you see them. So Shmuel, who is one of the scholars of the Talmudic era, so we're talking about the Persian era. This is after the Roman conquest of Judea. A lot of the Jewish community, the center of the Jewish community, shifted towards the Persian Empire, which was not under Roman rule. They were ruled under the Parthians. So that's in the area of today, Baghdad, Fallujah, and so on. There were large Jewish communities over there. One of the scholars in those Jewish communities was Shmuel. He was about the beginning of the Sassanid era, which is, I would say, the 500s AD, or a little earlier than that, actually, 200s AD. So he says that comets, he says, the paths of the sky are as clear to me as the paths of my city, Nahardea. Nahardea was the city he lived in, and he says the paths of the sky. This really resonated with me as an amateur astronomer. As you get to know the sky, you turn left at Orion. You get to know it. It's almost sort of like, there's that little alley. You go down that street there, and on the third door on the left, there's that little shop. This is something that amateur astronomers probably appreciate when you're trying to find a little galaxy or deep sky object. When you get familiar with the sky, you can find your way around, almost like finding your way around the streets of your hometown. I'm going to skip through here. Okay, there you go. So there it makes reference to those constellations, and it brings 2 biblical references. One where it lists Kima and then Xil, and the other one's where it lists Xil and then Kima. Chain the minds of Pleiades and so on. There you go. Shmuel says it's approximately, okay, so Kima, that's the one that we're dealing with. He says that comes from the Hebrew term kemea, like 100. So sort of a bit of a play on words. Some say they're concentrated and some say they're dispersed. So that sounds a lot to me like it's describing a star cluster. So that's where I get it, that it probably referring to, now Aish is the one that I suspect was the Pleiades. So it's either the Hyades or it's referring to some other star cluster that was very well known. All right, so here the Talmud is trying to identify what Aish exactly is. Here it is. So some say it is in the tail of Aries, and some say it belongs to the head of Taurus. That's exactly where you can find. Now, the tail of Aries would be the Pleiades, and the head of Taurus is probably the Hyades. So there you have it. So here I've put it out based on the several clues that we have. I'm not going to go too much into it, just because I want to get on to the next topic of the talk. But this is a very interesting discussion that a lot of and here I have several references. There was this paper, Ayud Bar Sinai, if you want to check it out, he's got a whole paper on trying to identify what these various references to these astronomical objects in the Bible are. And there you have some more references over here. All right, so the next little subtopic I'm going to discuss is the Jewish calendar. So the biblical references are there, and the Talmudic references are there, but they're quite sparse. That's not astronomy. We don't get from that to Zacuto and Levin ben Gershom. Here's where it gets more interesting. Now, the third factor that I'm going to throw out there of why the Jewish culture and religion have always been very strongly tied to astronomy has to do with the calendar. The Jewish religion centers very much around the events during the year, the holidays of the year, and which is based on the Jewish calendar. Now, the Jewish calendar, here I'm just giving a little bit of a timeline just to give perspective, because I keep throwing out the terms biblical, Talmudic, and so on. So just to give you an idea of what era we're talking about here, the Old Testament books were written throughout the pre-Greek times. Some of the newer books that were included in the New Testament that are not included in the Old Testament, such as the book of Maccabees, that's the Maccabees who was a revolution against the Greek rule over the province of Judea. So we're talking already Greek era. Those books were excluded from the Old Testament. So the Jewish Old Testament sort of ends at around the Greek conquest, about Alexander, the time of Alexander the Great, which is about 300 BC. Everything past that, what we're talking about is what I call the Talmudic era. Those were the scholars putting down those passages that I read to you earlier. And some of that was written in Judea, Roman Judea, and then a lot of that scholarship shifted to Babylon, Persia, which is where the rest of the story comes in, which is then eventually becomes conquered by the Arabs in the 600s by the Muslim conquests of Iran and Iraq. And that's where the Jewish culture then starts to shift towards more of an Arabic culture. And then from there, it spreads to Andalusian Spain, and then from there into the Christian world. So that gives you sort of a bit of a background. The first Arabic translation of Ptolemy was actually made by Chou ibn Bashar al-Israeli. So clearly, this first translation of Ptolemy, he was Iranian. He lived in the southern part of Iran, and eventually he came to Baghdad, and he was also a court. He was the court translator in the royal library and so on, and he was the first one to do a translation of Ptolemy's works. So again, a Jewish astronomer is responsible for Ptolemy's works basically coming down to us through the library of Baghdad. And then when you start getting to Andalusian Spain, you get to the Toledo School of Translation, and that was extremely influential. The Alfonso tablets and charts and so on and so forth. So let's talk about the calendar. Okay, so the Jewish calendar is based on mostly is a lunar calendar, right? With some adjustments made to update it toward for the solar calendar. So there's months added to extend the calendar. So let's see how exactly that works. So the synodic month. Synodic month means the point in the month when the moon is a new moon to when the next new moon. So a new moon happens when the sun and the moon are in conjunction with each other, and the moon passes from the, I guess to the right, I don't know, east, west, let's see, it would be, we call that east, I guess, to the west of the sun. The moon is moving about 13 degrees each night. So from one month to the next month is, synodic month is about 29.53 days, which is slightly longer than what we call a, I think it would be called the sidereal month, which is when the moon is from the same place against the fixed stars. But because the sun is also moving with respect to the fixed stars, the moon actually has to go an extra constellation. Each month, the sun is in the next constellation over, so the moon would have had to make its way around all 12 constellations, plus the next constellation where the sun had moved over. So that's what we call a synodic month. And that's 29.53 days. And based on the Jewish astronomy, Maimonides, who was another scholar who lived in the 1100s, he gives that as 29 days, 12 hours. There you have the 12 half days. And then you have a little bit more, slightly a fraction of an hour, almost an hour. And he gives it in 10/80th of an hour. And this is very close to modern astronomical measurements. This is within, you can see, 0.0002%. So this is extremely, extremely close. It's actually quite remarkable how close it is. I'm going to go here if I can find the passage here. This is here. This is what I found online. There's a very good. I put it in the reference. This is a translation of Maimonides. So he writes, day and night are 12 hours. Here it is. An hour is divided into 1080 units. The reason is the number is chosen because it can be divided into halves, fourths, eighths, thirds, sixths, ninths, tenths, and so on. So everybody knows 360 degrees is a very convenient number to use because it's divisible by all the different numbers. It's anti-prime. So 1080 was also used because that was able to give very precise measurements, as we see, as precise as 0.0002%. So 1080 is an extremely, that just makes it a little confusing when I was doing research on this. It's very confusing to talk in 10/80ths of an hour instead of minutes. In my mind, I was like, how many minutes is that exactly? And I'm using decimals too. I'm using 0.53. So in my spreadsheets, I had to constantly do those conversions from what's called halakim, parts or fractions of an hour, down to hours. So according to this calculation, interval to one conjunction of the moon and the sun to the subsequent conjunction, according to the mean movement, is 29 full days, 12 hours of the 30th day. That's an extra half a day. And 793 units of the 13th hour. Right? This is the interval. So that is what the entire calendar essentially is based on. So once we have that magic number, we can then figure out the rest of it follows. So months will alternate between 29 days and 30 days. So if a month is 29 days, if you start a month theoretically on a new moon, if you give it 29 days, your new moon is not going to be really until a little bit later. So you've lagged a little bit. So what you do is the next month, you make it 30 days. You catch up. Now you're a little bit ahead. And then you keep shifting back and forth. So sometimes you get 29 days, some days you get 30 days. That's 11-day difference from the solar calendar. All right. So because the solar calendar is 354 days per year, is 12 lunar months. You do the multiplication. We're 365 days in the solar calendar, your 11-day difference. That's where extra months are added to adjust it to the solar calendar. So every few years, you get an extra month. You get 13 months instead of 12 months. All right. So historically, going back to, this is the early part of the Talmud. This is the part of the Talmud that was written, say, in the 2nd, 3rd century AD. So before, this was already the part that was written still in Roman Judea. This was before the Persian era. This is what's called the Mishnah, which is the original part of the Talmud, writes that 6 months of the year, there were 6 given months, because those are the months that have holidays in them. Emissaries would go out to all the different cities of the Jewish diaspora, all the way to Persia, all the way to Babylon, and even Asia Minor and so on, to give them the news about whether or not the month was made 30 days or 29 days, as I discussed. It's 30 days or 29 days. It was adjusted back and forth. Right? And it lists, Passover. It was done in Iyar due to Nisan because of Passover and all the different holidays. It lists over there. Those were the months. So the months were established by the High Court in Jerusalem, which sat in Jerusalem, who was the council that was responsible for determining whether or not the new moon, should be declared on the 30th day or on the 31st day. Right? So that worked by if the moon was sighted. So the moon was sighted. There were witnesses that actually had gone up onto a hill, had seen the new moon. That's actually a fun activity as an amateur astronomer. I've done this once, trying to see how early in the month you can actually make out the new moon. That's quite a bit of fun, actually. You got to get it in the day. So you go on like the day right after the new moon happened, and you go out towards the evening time when the sky is starting to dim, and you look for the sun, and then you look sort of a couple of degrees to the left of the sun, and sometimes you can make out the new moon, sometimes you can't. Right? And if you can spot it, that's quite a bit of fun. So usually we're trying to spot things in the dark sky. Here we're trying to spot the new moon in a really bright sky in the middle of the day. And if you can spot it, once you get it, it's really quite amazing. Sometimes it just looks like a little cloud even. But that was very important back then. Back then it was important because they had to know whether or not the new moon should be made. So it's very easy to manipulate this, right? It's very hard to see. If they needed the month to be long, they needed it to be 30 days because they knew based on their calculations that the new moon wasn't going to happen, or you needed to extend the month by a day. They would just say, well, we're not accepting testimony, right? And it's like, well, too bad, nobody saw it. And this month's going to be a 30-day month. And if they needed it to be 29-day month, they would do everything they can to try to see it. And they were, okay, people would come. There's even a story in the Talmud where 40 people came and they had to house them in a courtyard, and they would put a meal for them. They would make them do as much as they can to encourage testimony because they really needed this month to be a short month. Now, the same thing, that council would also be responsible for determining when a new month was added. And that was determined based on more seasonal things. That was done every couple of years. If it was already not the spring equinox, if the spring equinox is not yet for another month off, but the Passover holiday, Passover is in Nisan coming up. Passover is in a few weeks, is a spring holiday. If the spring equinox hadn't yet come, they'd add an extra month. And coincidentally, this year is actually one of those years where there was an extra month added so that we can push off the spring equinox. Easter this year was actually just last week or this week. And that was usually the calculations of Easter, which were also based very much on these calculations, are usually aligned with Passover. This year, Passover is an entire month after Easter. And the reason is because the Gregorian calendar, which what the Easter calculations are based off of, hadn't added a leap year this year, went for this month's new moon for its calculations, while the Jewish calendar added a new leap year, so we're a total month. Next year will be 11 days closer, and then we'll sort of bridge the gap until the next leap year comes in. So all this was, and here's an interesting story. Rabbi Gamliel, he was the chief of the court of Jerusalem, had a chart, a moon table in his chamber, and when people would come in to testify, he would show them the various images of the moon, looking in this direction, in that direction, and he'd ask them, what did it look like? How big was it? And that way he'd be able to find out if they were lying or not. If they'd say it was facing this way, he knew that that's not the new moon, that's the old moon, right? So did you see this form or did you see that form? He would ask them. So there was an incident in which two witnesses came and they said, we saw the waning moon in the morning in the east. And the same day we saw the new moon in the evening in the west. So Rabbi Yochanan ben Nuri, who was another member of the court, said they are false. That doesn't work like that, right? That's impossible. So when they arrived in Yavna, which is where the court was sitting after Jerusalem was conquered by the Romans, the court had moved to another city called Yavna. Rabbi Gamliel, he accepted their testimony. Why? Because he was trying to get that month to be a new moon. So he said, well, maybe they meant this, maybe they saw clouds and they didn't really see it. So you had sort of an argument between these two rabbis of the court, whether or not we're going to accept these witnesses, whether or not we want this month to have an extra day or not. All right. This is another passage. I'm not going to read everything here because I don't want this to take too long. What time do I have? How much time I have? Okay, I better wrap this up soon. All right. Here's another passage of Talmud where it says that the full months, we don't want to have more than, you don't have less than 4 in a year, and you shouldn't have more than 8 in a year. So on average, you would have 6 full months, 6 half months, because it's about 29 and a half days. So about half the months would be full, half the months would be deficient. But sometimes you'd have less, sometimes you'd have more. To have less than 4 full months would be too few, because then the next year's the new year would fall out too many days away from the actual astronomical new moon. All right, so this is what months were manipulated to keep holidays. Now, here's another passage in the Talmud which explains why these days would sometimes be added. Sometimes these days would be added because you'd want the holidays to fall out on certain days of the week. All right, so this is the story. Ula, who was also one of the scholars a little bit later in the history, he came to Babylon and he said, this year the court in Jerusalem, he came from Jerusalem to Babylon, and he told them that they made this month a full month. Right? And he says, do you guys know, do my Babylonian colleagues understand how much the benefit that I've done for you by adding this extra, by making an extra day. Why? So what was the benefit that they had gotten adding the extra day? So some say it was mishum yarkia, is the vegetables. They shouldn't spoil over the holiday. They'd have to pick their vegetables. Then they didn't have refrigeration. If they'd have to pick their vegetables before the holiday, and you'd have the holiday and the Sabbath falling 2 days in a row, you'd go 2 days without fresh vegetables, and the vegetables that you picked on Friday would spoil. And some say, Rav Acha bar Chanina Amar, the other scholar says, Mishum Masiyah, it's the dead, the bodies of people who died. You'd want to bury it that day, especially in Babylon or in Judea. The weather was different, and the bodies would start to smell. They weren't able to bury them on the holiday or on Sabbath. If you'd have the Sabbath and Yom Kippur falling 2 days in a row, you go 2 days without burying the dead. That's no good. Right? So that's why they would add Elul, the month before the New Year and Yom Kippur. That's the one that they would try to add or detract from, because that will determine when Yom Kippur will be. So we don't want Yom Kippur to be on a Sunday. We don't want it to be on a Friday. Also, the other holiday in Tishrei, which is the first month, is the holiday of Shmini Atzeres. We also don't want that to be on, or actually Hoshana Rabbah, the day before. We don't want that to be on a Saturday. So there's 3 days of the week that we don't want those holidays to be on. So they would just add an extra day, whether or not the new moon happened or not. So at a certain point in history, this became very inconvenient, especially since the Jewish diaspora started spreading throughout the Roman world to other Roman provinces, right, such as Gaul and Spain and so on. So what happened is that once you start getting into the post-Talmudic era, they needed a fixed calendar, which means they had to be able to calculate it without witnesses having to come and emissaries be sent out. They needed to have tables to tell them, this year, these are the days, this is when the new year is going to be. So it's attributed based on the consensus is that sort of around Hillel II, who was the patriarch in Judea at the time, at around 358 AD, which by that point was actually post-Hadrian. Hadrian renamed the province to Palestina. So Hillel was the patriarch of Jerusalem. He is the one who basically determined that, you know what, we're going to stop this system of testimony and witnesses, and we're going to start using a system of just a fixed calendar. However, there's clues, there's little thises and that's that were worked out. Certain days of the week did work, certain days of the week. The actual system that we have today, Al-Khwarizmi, which is a famous, our term for algorithm is named after him. He wrote on algebra. He was a very famous Islamic scholar who lived, again, in Baghdad in Persia. In 823, he describes basically the system that we have today. In this presentation, I've based it off of Maimonides, which I read to you earlier. He goes on for several chapters explaining exactly the system. But this dates actually before Maimonides. Ibn Ezra, who I mentioned earlier, had written a whole book on the Jewish calendar, and he was in the 1100s. So this system had already been in use for a couple hundred years. So the first thing that we're trying to do by fixing the calendar is making sure to figure out when these extra months will be added. That's important to make sure that our spring equinox lines up with our Passover holiday. We don't want every year to be 12 months. 12 months, we're going to lose 11 days each month. Eventually, like the Islamic calendar today, for example, Ramadan sometimes is in the spring, sometimes is in the winter, because the Muslim calendar does not add these extra months. So you end up getting a drift in the month of Ramadan. Sometimes it's spring, sometimes it's in the summer, winter. The Jewish calendar, we get these added months so that the Passover holiday is always in the spring, like Easter. So the calendar they settled on was what was called the Metonic calendar. Meton was an ancient Greek astronomer from the 1st century. Actually, not ancient Greek, that was Roman era Greek, but that was, I guess, Roman Greece. This is somewhat, I guess, probably the era around Ptolemy. He had calculated that the solar year, what we call the tropical year, 365.2422 days. Here's the chart. I did it myself on a spreadsheet. Meton did not have that benefit. But if you take a look at the number of tropical years, you assume that a tropical year is 300 and 65, the number of days, here it goes, 365, one tropical year, number of days, 365.2422. And what you do is then you multiply. And the number of lunations, that's based on the 29.5 plus the 793 10/80ths of an hour. That's what I have in the second column. And if we keep extrapolating out, eventually, when we reach 19 years, you get 234.997. We're almost spot on for a whole number of lunations. Lunations is a synodic month. So that's a perfect number to choose. The number 19 was chosen by Beaton, because that is almost an entire whole number, which means if I have 235 months in a 19-year cycle, I'm going to align with the equinox every 19 years, exactly. And it's off by 0.0024. If I use 235, it's actually slightly smaller. We're a little bit off. So it does drift a little bit, but over centuries. So here you have it. Here's our 19-year calendar. So year 3, year 6, year 8, year 11, year 14, year 17, year 19. Those are determined to be the leap years. And the rest of the years are 12 months. And we add those extra 13th month in every 2 or 3 years. All right, there you have it. That's our metonic cycle. And this slide is just showing how it lines up with our Gregorian calendar. Our Gregorian calendar, we're also off by a few days over there too. Gregorian calendar works on a 400-year cycle. That does not take lunations into account, but you can see it still works out very closely to the Gregorian calendar is the adjustment made for leap days because of the difference in the 365 and a quarter is not really exact to the tropical year. The last adjustment that has to be made is what I mentioned earlier, the days of the weeks. Right? So this is the modification that was made to the metonic calendar in order to adjust the years to certain days of the week. So going back to this slide, here we have it. Some years are leap years, some years are non-leap years. Some years will have, remember what we mentioned before, some years have 4, 5, 6, 7, 8. We said that the full months are not more than 4, not less than 4, not more than 8. What they actually settled on for this fixed calendar, as my monitor described, is actually only 3 versions. Either we're going to have, oh, I made a mistake there, that should be 12, that should be 13. The number of full months is actually not 4 to 8, but they've actually limited it to 5, 6, or 7. They kept it more simple. So either we have a year with 5 full months, 6 full months, 7 full months. So the number of days in the year can be adjusted anywhere from 353 to 355. And if we have a leap year where there's an extra month, the extra month will always have 30 days. Then you have that. Now, I added the modulo 7. Modulo 7, what that gives you is what day of the week the next year will be. So if the new year was on, let me pull the chart up. If the new year was on a Monday, there you have the modulos. There's the 3, 4, 5, 5, 6, 0. That next new year is going to be on Thursday, right? If it's a leap year and we use only 5 full months, it's on a Saturday. If we put 4, 5, or 6, 5, 6, or 7. If we put 7 full months, then it's going to be on a Monday. Now I've crossed out some of these. That is to satisfy the other condition that I mentioned earlier. We don't want Yom Kippur to be on Sundays and Saturdays, and we don't want the other holiday to be on Saturday because we want to be able to bury the dead or because of the vegetables and so on. So certain of these year types we've eliminated. We've crossed it out. So those are unacceptable combinations of the years. And actually that year where you have a leap year, also starting on a Tuesday, we also don't use a full 6-month leap year. So here you have the chart. So this is basically based on Molad. This is the new moon of the new year. We look at what time of the day it is, and we add either full or regular so that the next new year shouldn't be too many days away from the new moon. And this chart, which is described, also Ibn Ezra describes it, Maimonides describes, this is called the 4 gates. This is a little bit more complicated. This has to do with how we want 2 years certain in a row, based on whether the year is before a leap year, after a leap year, and so on. This gets very technical. I'm not going to dig too much into this. But this is sort of the other adjustment made to the metonic cycle. So there you have it. Again, there's a lot more to be said on this, but I probably got to wrap it up over here. Here's your references. There's a lot more to be said here, but I'm going to just read a passage actually, just to close this off. I don't have it on the slide, but there's a passage in the Talmud which I found very interesting, which reads as follows. There's an obligation on a person. So this is talking about there's a religious obligation for calculating seasons and zodiacs, which means all these mathematical calculations. Somebody actually, an astronomer, when a Jewish astronomer goes through the trouble of working out these calculations, they're actually fulfilling a religious duty. Right? And it quotes a Bible verse. It says, "And you shall keep and you shall do the Torah, the rules of God, for it is your wisdom and your understanding in the eyes of the nation." Which branch of wisdom and understanding is appreciated by all the other nations of the world? That is the calculation of the seasons and the zodiacs. So the Talmud finds a biblical source that there's actually a religious obligation to calculate these things because it benefits all the nations of the world. As we saw earlier, the Jewish astronomers essentially opened up the entire world of astronomy from the Islamic world all the way to the Christian world. A lot of the stuff we have today is thanks to these Jewish astronomers who tabulated. A lot of this is very tabular. I wish I could put more pictures of where all astronomers, we like to look at the sky. But when you get into the minutia of it, a lot of it is really tabular data. And Jews are very good at that. We're very good at working out all those log tables and those trigonometric tables and so on and so forth. And this is where it comes from, really. This is where it comes from. It's calculations of the motivation here was the calculation of the calendar. So I hope that was informative, and thank you very much.
Thank you very much, Joel. Absolutely fascinating how things used to be done way, way back then. Don't go away. We may have some questions for you. All right. Any questions?
Questions
in the room? Okay, here we go.
So what is a tropical day? I believe in one of the slides you had it.
365.2522. So the extra 0.00, so 365.25 works out very nicely. So we have 365 days a year. The extra 25 we do by, this is the Gregorian calendar, and the Julian calendar did this as well, by adding an extra day, February 29th. It used to be an extra February 24th, because that was a certain holiday in the Christian calendar. But the extra 0.22 we didn't account for, and that's where you had the drift. The Julian calendar was drifting off. So Pope Gregory in the 1300s, I believe, added a whole bunch of days to account, and what he did is he basically took away some of those extra days, and every century, while every 400 years was a leap year. So the year 2000 technically is a century year, so should not have been a leap year, but the last 2000 was a leap year. We did have a February 29th. And if you do the math there, it works out to, if you look at the Gregorian calendar and you take that 400-year cycle and you divide it by the total number of days there are based on the number, there's 303 regular years and 97 leap years. So do 303 times 365 plus 97 times 366, and then divide that by 400, you're going to get 365.2525 actually. It's actually 24, I'm sorry, it's 2422 or 2425, because we needed to take away some leap years. So we're actually a little bit less than 200, than the 0.25. So I'm sorry, apologies. So that's what the Gregorian calendar was there to correct.
Okay, I have another question. It's a little bit off topic, but if you're born on a leap day, how do you celebrate your birthday on the next year?
So the Jewish calendar, there's actually a leap month, right? And the way that works is that we always considered, so for example, this year, as I mentioned, was a leap year. So there were 2 Adars. Adar was the month before Nisan. The reason that month was chosen, because it's the month before the spring equinox. So we add the extra month to push off the Passover holiday so that it's after the spring equinox. That second one is the day that the holiday in Adar, this year there was a holiday of Purim. You might know what it's about. That's the holiday where people dress up. The story of Esther in Persia and the King Xerxes. That's a famous holiday in the Jewish calendar. It's a lot of fun. Kids go around, collect candies, and so on. That was celebrated in the second month of Adar. So in the Hebrew calendar, it's the second one that's counted. In the Gregorian calendar, if there's an extra February 29th, I don't know, do you celebrate your birthday on February 28th or March 1st? I would say March 1st. I don't know.
What do people do usually?
Okay, we got the question right here.
So, is this why Hanukkah keeps jumping around in December, from late December to mid December to early December? It's the 11 days cycling through, and then you add the month, which reboots it back to the end.
Yeah,
right?
so Hanukkah's in the winter. So it's anticipating the extra month at the end of the winter before the spring equinox. So if we're in a year where an extra month has to be added, that extra month has to be added because everything is too early in the year. We're too early in the year, so we have to add that extra month. So usually in that year that approaches, put this slide over here, especially when we've gone, for example, year 4, 5, we've already gone 2 years without a leap year. So we're about 20 days off, right? The next year, you've added the extra 30 days. That next Hanukkah of the year 6, in year 6, Hanukkah is going to be in the winter, like where you see a number 72 over there, or 71. I'm not sure which one of those is the month of Hanukkah. Hanukkah is going to be very late in the year, but in the next year, year 7, it's going to be very early in the year. And again, Ramadan doesn't do this. And if you notice, Ramadan each year will drift.
Question here at the front.
No, just a quick comment. And I thought figuring out Easter was complicated.
Yeah.
Boy, this is pretty fascinating stuff. Sure.
Yeah. I'll note actually about the Easter here we have year 1, 2, 3, 4, 5. So basically you take the year and you take mod 19 and you get the number, whether or not year 1. In the Easter calculations, that's called an there's called Euler's algorithm for calculating Easter. He calls that, or it's called the magic number or something like that, or there's like a special name. That number, the number of the year that you are, is a special number.
Have any questions online?
We have one comment online from Eric Briggs. In relation to the anti-prime numbers, like 360 and 1080, Eric says 1080 is also a video resolution standard because it has so many factors. For the ratio 16:9, it's divisible by 9, but gives you 67.5 when divided by 16.
Yeah, that's interesting. And 1024 is a binary number, but it's close to the 1080. So sometimes you get some conversion factors over there. If you're using binary to encode your 1080, then you get a little bit of a. Sometimes you can get a little bit of a. Yeah.
We have a question here.
Hi, so I might have missed this, but how come having Yom Kippur on like a Friday or Sunday result in the dead not being buried for 2 days?
So Sabbath, which is every 7th day, no work is allowed. But to the Jewish, it's the Sabbath day. It's the rest day. So dead are not buried on that day. Yom Kippur is also a rest day. So that's a day for fasting. That's a day for prayer. Everybody goes to the synagogue. You're essentially praying all day. There's no burial of the dead happening. So if somebody would die late on, let's say, Friday afternoon, and you'd have Saturday, and then the next day would be Yom Kippur, they wouldn't get buried until Sunday. The dead body would have to be sitting around for over 2 days. And in warm climates, that would not be nice.
Okay. Thanks.
Okay, so why don't we wrap it up here? Joel, very impressive. You seem to know this stuff inside and out. Very good.
There's a lot more to it. I'm just touching the surface.
Amazing.
All right, thank you.
All right, thank you again. Let's go. Let me go where I'm supposed to be. All right, our next speaker is Ralph Chou, and he'll tell us all about the EC Carr Astronomical Observatory.
Well, good evening, everybody. Just a question to get started. How many of you have been to the EC Carr Astronomical Observatory? A few people. Okay, well, this will be mostly for the benefit of the people online then, and anybody else who hasn't been there. I guess I'm one of the people who has been associated with the Carr Observatory since its very start. And so this is sort of a trip down memory lane for me, and I hope that you'll find it an enjoyable experience. The story starts in September of 1997 when I got a phone call late one afternoon. And it was Cliff Carr, a life member of the Toronto Centre, and he opened the conversation by saying, "I'd like to discuss donation with you." And as the story unfolded, uh, Cliff had uh, set up an observatory on a piece of land that he owned to the southeast of Thornbury, Ontario. Uh, and it was part of a holding that his family had accumulated over the years. And he was enjoying this observatory. In fact, it was a very unique structure in the sense that his telescope was on the top of a 2-story high tower, actually something like a concrete silo. They had a cottage at the base and a spiral staircase that went up to the observing floor. And this was all very nice. And the problem was that he had a neighbor across the road from him who had a 500-watt yard light that was right on Cliff's meridian. So for those of you who don't know, the meridian is the north-south line, and a lot of objects that you want to look at or image, well, the best place to put it when you want to observe it is on the meridian. And you had this hideously bright light shining right along that north-south line. So Cliff had managed over the years to come to an agreement of sorts with the owner of the property that he could switch off the light when he wanted to observe, and then he would switch it back on when he was done and go home. And this worked for a few months until the neighbor finally decided he wasn't going to play this game anymore, and he jimmied the switch so it no longer worked. Cliff was frustrated, and because of the nature of his business and the family holdings and so on, he literally bought the farm. He decided to show up at the man's door one day with a check and said, "I'll give you this much for the property." And so he bought the farm, and now he had two more, he had an extra property. What am I going to do with this? And at the time, we had been talking about the possibility of replacing our existing dark sky observatory at Schomburg. And so Cliff came along with this offer. Well, it was tantalizing. And on a cold November day in 1997, the Council of the Toronto Centre made a field trip out to Thornbury in the middle of a raging snowstorm, or the tail ends anyway. At any rate, your entire council was on the road that day, and the corporation would have been in big trouble if there had been any untoward incident along the highway. Here's the site when we first saw it, and you can see the snow. It had actually eased off by then, but the road was a sheet of ice. And for those of you who have been at the property, you know the place has an access road that has a lot of bumps in it, big bumps up and down hills. And so this was not a friendly place to come when you had city drivers, some of whom did not have snow tires. Anyway, we got inside and the house was semi-finished. As you can see, here's the present-day kitchen area. There's nothing there except the drywall. The basement is somewhat unfinished, but there was a potential. And after a few weeks of discussion, the donation was legally finalized, and we acquired the property just before the turn of the new year. And the following May, we had our first open house on the property. And a lot of people turned up, over 120 members actually that day, including Fred Troyer, who was our longest serving councillor at the time. Fred was marking his 60th anniversary on the council. He held virtually every major portfolio and position in the Toronto Centre during the course of his lifetime. And he was really pleased to see that we had this property. Cliff officially turned over the keys, as it were, at the ceremony to Marianne Harrington, who was the president of the time. And we had a great time that first day. You can see it was a sunny day. It was beautiful. And the vista that day was really, really nice. Well, then the problem was, what do we do with it? And here's a site plan of the place as drawn up by another big player in the history of the Carr Observatory, Jeff Brown. And here Jeff has basically marked out everything, including the all-important tile bed for the septic tank on the north side of the property. And of course, the warning is you do not put anything into the ground of major depth in that area. And you can see that we have the pond and the excavated material to the south of the house. They had to dump the excavation for the basement and foundation of the house someplace, and they just put it out there in the middle of a field. Anyway, that was the property then. And we're thinking, okay, what are we going to do with this place now that we've got it? And in the summer of 1998, we actually started work on the property. We installed a red light system inside the house, red light fixtures outside as well. So we had dual white and red light systems. We had a fairly substantial library, and we moved it up to the site and installed it in the basement. We began installation of a full kitchen upstairs, thanks to a donation of kitchen cabinetry. And we started planning for the first observatory. And I remember the night that Marianne and I went up to Thornbury to do the presentation to the Thornbury Planning Committee to apply for the building permit, because that was also the time when we discovered that we'd been broken into. Our first and only break-in, they got into the garage and stole a lawnmower. And we duly reported to the OPP, who actually found the lawnmower at the perpetrator's weekly garage sale the following weekend. Anyway, that also led to us installing some anti-burglary measures later that summer as well. And we haven't had a break-in since, knock wood. Well, the question was, what are we going to do about a telescope for this planned observatory? And we had all sorts of ideas that were flying around. But Cliff once again came to the rescue. He phoned me and said, I'm getting a DFM. So this is an expensive Cassegrain telescope system, a 16-incher. It is not cheap, let's put it that way. Would the center need a large telescope? Because at the time he had a 16-inch LX200 Meade telescope. And so he offered it to us as a donation as well. Well, you don't pass up something like that, do you? And so we said, well, thank you, Cliff, that's great. And we put that into the plans, which immediately meant we had to upscale our plans for an observatory. Once again, Jeff Brown came to the rescue and conceived the idea of the now what is known as the Jeff Brown Observatory. And in July 2000, a crew from a company down in Mississauga that builds super jails, among other things, showed up with the steel frame. And what had happened was that Jeff used his contacts through his architectural business. He dealt with a lot of companies that worked for the provincial government. And the owner of this particular company was particularly entranced by the idea of building an observatory. And he not only donated the materials for this steel frame, but he also paid for the crew to come up and install it on site. And so within 6 hours, we had the frame of this observatory, including the sliding roof, all ready to go. And there's the crew with their finished product. And then it was up to us to do the rest of it. Jeff Brown immediately tested out the roof, and you can see that one manpower does indeed slide this structure back and forth. And in fact, for a number of years, we actually used a boat winch at great personal risk to move it back and forth until eventually one of our other members, Tony Horvatin, came up with the idea of a chain drive to take the work away, as well as the danger of a boat winch out of control. Well, anyway, as we were building the walls and the roof of the observatory, we also had to worry about installing the pier, and there's a lot of work that went into actually getting the steel plates and the base of the now telescope pier truly vertical and stabilized within that observatory floor. And there's the finished product in, I believe it's 2000. We finally got this thing done, and the observatory pretty much ready to go. Then it was time to actually clad the structure with siding and install the telescope. In July of 2001, here's the observatory as it existed then, with the observing room and the LX200. And you can see that we have an observing room, a dark, a warm room where the control computer is, and lots of hardwired power and internet connections within the observing floor. And we have these drop-down desktops, which we still use today. Plenty of place to put out observing charts and equipment, eyepieces, et cetera, et cetera. And the idea was that not only did you have space for the telescope itself, but there was a lot of floor space there so that other people could use their own smaller telescopes within the observatory as well. Here's a picture of the warm room. It hasn't changed very much since those days. The only exception is that every once in a while we have to sweep out the hundreds of cluster flies that die on the premises. That's one of the problems of being out in the country. And here's the completed observatory ready for first flight. So a lot of man hours went into finishing off this particular structure, but it was all good and it served us well up to this point. The telescope itself, eventually we decided that we needed to upgrade it. There were problems with the LX200's drive system. It went out west and eventually found a home with, I think it was the Regina Center's telescope observatory, and then they in turn moved it out to the west coast. And last count, it was, I think it's at the Sunshine Coast Observatory, but I'm not entirely certain. But at any rate, there we are. And we've replaced that telescope since as well. But it's great the way it is. Well, what goes on at the CAO? Well, there's a lot of membership activities that were going on before COVID shut us down. We had frequent open house and awards presentations at the site, along with a picnic program, rocket launches and so on. We've had digital imaging workshops there, various courses. Members have done Perseid and Leonid meteor shower observing there. And over the years, we've also developed an additional facility, the Sue Laura Observatory, donated by the wives of two of our members. If you can't beat them, join them. And that observatory is dedicated to imaging, and it now has an 8-inch Schmidt, 8-inch Ritchie-Chrétien telescope in it for digital imaging. Of course, there have been adventures along the way. Jeff Brown discovered this in the year after we started operating things on the floor of the Jeff Brown Observatory as we came to know it. Notice the snowdrift, which is about 9 feet high at this point, or 3 meters, and Jeff has cunningly cut a staircase over it so that he could get through to the observatory's entrance. And this is one of the things that continues to this day, although this last winter we didn't have nearly as much snow. But typically there's 1 to 2 meters of snow deposited on the grounds during the winter. So it can be a challenge to get onto the site. In 2007, we were fortunate to get a Trillium Foundation grant, which financed the building of this structure along the front and side of the house. So it gives us full access for physically disabled people. We've got a wheelchair ramp as well as the deck, which allows you to get around to the main entrance of the upstairs level. And then down below is another entrance for the lower level where the library, another bathroom, and the meeting space happens to be in the building. So you can see that on the right side, we have the names of all the people who are involved in the building of the ramp. We had a contractor put in the frame, and then we went in on our own, as we did with the house, and basically laid the planks for the decking. And there are a number of people who are listed here, including yours truly. One of the benefits of doing all this work at the site is you learn some skills. I learned how to mud drywall as one of my tasks. And in fact, I ended up taping the entire big meeting room down in the basement of the place. So yeah, I do have a useful skill. And in 2008, we observed the 20th anniversary with the OHAP, as it came to be called. You can see here all the awards recipients and the other people who took part in that particular program. Well, a place like this needs constant improvements. And Charles Darrow, one of my successors in the presidency, came up with the concept of the modal, or my own dome lot. And here's how Jeff Brown and Blake Nancaro envisaged this. Blake actually produced this drawing of the site with the idea of where these particular domes could be. At this point, we've actually installed the 5 modals, 1, 2, 3, 4, and 5. And we do have room to expand if we wish. And in addition, you can see here on the diagram, there are also some other things. There's the GBO, which is the main observatory. There's the observing pad, which is approximately 50 feet long and about 8 feet wide, and it's aligned exactly east-west. So the pavers on that are marked north-south. So you have meridian built into the observing pad. The THO is an observatory that used to be on Tony Horvatin's brother's farm, and he moved it over to the Carr Observatory property a number of years ago, and you can use that for parking a telescope if you're on the property for an extended period of time. So we have followed with this development plan to the very day, and we actually are looking at the possibility of installing modal number, let's see, we've since put in modal 6, I think. And I think the next one is modal 7 that might go in. So anyway, we're following along in the plan at this point. And each of these has power and internet connections that we have wired in through the property. So a lot of work has gone into all of this stuff. The Soulor Observatory was built in 2018. Here you can see the telescope, the 8-inch Ritchie Chrétien, and to just bolster the capabilities of this imaging facility, we recently had Don Stewart, our IT man. He acquired a couple of servers that we've installed in the library of the house, and we've got 8 terabytes of storage capability on site now. So you don't have to worry about running out of storage space with your images. You can image all night and then just download the stuff either before you leave or remotely from home. CAO today, this is an aerial shot of the property showing pretty much our entire property. So you can see the house, you can see the modals and some of the other ancillary buildings. There's the infamous pond. And the tree line that you see down the left side of the image, that belongs to us. What happened was that originally our property line fell short of that. It was about midway through that field to the right of the trees. But that was owned by Cliff. And what he did was he sold us at a discounted price a strip of land from the adjacent property that includes the left side of that tree line. So it's a permanent buffer against any light that might emanate from a property that's built on the property next door. And so he was really thinking long-term about the viability of the observatory. It's on Niagara Escarpment property, so we have very few neighbors that are going to be developing anything. That big hill of trees that you see in the center of the photograph is Bruce Trail land. And in fact, the trail runs just to the right of those of that brush that's midway up the hill. And our property line is where that green field structure is between the pond and that string of shrubbery. So it's a well-protected investment for us. And our property goes down probably another third of the way to the lower right in this image. So it's a total of about 53 acres or thereabouts. So in addition to all the activities that our members have, we've been also using this place as an outreach facility. And we've had a number of users, particularly Scouts Canada groups have come to us from Toronto, Streetsville, Barrie, and Collingwood to use the property for astronomy camps. We've had some private engagements, and more recently, we've started to do presentation to Probus clubs who are very enthusiastic and are very generous. And so we're continuing these kinds of things once we start up with our summer programs at the beginning of May. We also have some professional collaborations that we've been carrying on. Since 2005, we've had an all-sky Sentinel camera from the University of Western Ontario's Meteor Recording Project. It's part of a network that they operate, and we've contributed to the recovery of a number of meteorite falls over the years. So it is a significant contributor to meteor science. And you can see this example of a meteor that triggers the camera and records the trajectory of the incoming meteor. And using triangulation with the other stations, they're able to tell a lot more about the actual path of the object, and they can even tell if there was a fall and where to look if they can recover it at all. Since then, we've done a few post-COVID improvements to make the place a little bit more safe for users. More importantly, we've got UV sterilization systems on our well water supply, as well as in the furnace to handle the circulating air in the place. Bit of isolation between the levels of the house so that we can also control the the spread of any possible disease organisms. We have upgraded the wireless and the wired networks, and again, we've had the installation of the 8 terabytes of on-site server storage. More recently, after a number of months of negotiation, we entered into an agreement with the University of Toronto to host an observatory of theirs on the property. And this was funded by a grant from the Dunlap Institute, and it proceeded very, very quickly. Once we had the agreement in place, the deck was installed within a week in August. The dome, which was donated to the U of T from a company that was using it for other purposes in the Toronto area, actually transferred the ownership, and the university moved the dome and erected it on the deck in late August. We had a work party in October that was not only our members, but also I think it was about 10 graduate students and staff from the university. They were up to their knees in mud as we excavated the trench to put the power lines in. But we got it done in a day, and they have their power and internet installed in that October work party. And they installed their telescope, a plane wave reflector, in February. And they're now just getting it up and running and getting rid of the bugs. So that observatory will be operational this summer. Now, why is that important? Well, a lot of astronomers end up with small observatory telescopes that they have to use instead of the 10-meter babies and so on. That's practical reality. And so one of the purposes of this observatory is to teach astronomy students how to manage and design a research project using a small telescope. So the plane wave is not only going to do imaging, but also will have photometric and spectroscopic instruments available to it. And they'll be bringing their students up for overnight observing runs, as well as doing remote observing with this facility. But more importantly, we have some benefits to the center of this project. For one thing, all of those users will become members of the Toronto Centre. So that gives us some membership revenue, which is good. We have the working collaboration opportunities with research faculty at the U of T, and they are very, very encouraging and very enthusiastic about the possibilities. So that means that as members of the Toronto Centre, you have an opportunity to get involved with actual research programs if you'd like to do so. More importantly, we'll get to use the telescope when the U of T isn't using it. And because of the way that dome is set up, it can be run remotely. You can use that telescope from home once it's up and running. So again, it's a big plane wave. It's bigger than our telescope in the GBO. So there's good potential there. And the University of Toronto is sharing our operating expenses as a result. They are going to help us with the 5G internet connection that will vastly improve our internet services on the site. And more importantly, they're willing to help us foot the bill to clear the road in the wintertime. For the last 25 years, we have had to either park the car at the base of the hills and walk in, or just not go. But this January, we started plowing the road, and so we have on-site access to the parking lot and the road all the way from Laurie. So you can drive in. The only thing you have to do is remember, you need snow tires and a four-wheel drive to negotiate the road. But we can now get into the property and actually not leave the cars anywhere in the neighborhood. So that's a really big bonus for us. So we'll begin supervised weekends on site in May of this coming year. And we have a spring work party that if you're interested, we will be happy to teach you some of those tricks that we've learned over the years about, running this property and some of the tasks that we have to do to get it ready for the summer observing season. We have an open house and awards picnic scheduled for Saturday, 6th of July. And that's when we're hoping to actually do presentations of the Toronto Centre Awards for 2022 and 2023. We'd like to do those in person on site. We plan to offer new user orientation sessions throughout the summer, and those will be announced through the email forum. And we do have one of the modals that is available now to lease. The current occupant has decided that they no longer feel that the modal meets their needs. And so the observatory itself is available for sale, and the site is available for lease from the Toronto Centre. So if anybody's interested in that, you can talk to me about it, and we'll be happy to give you the information. But basically, that's it about the CAO. We hope that you will enjoy the site. We've made a lot of improvements over the years, and it's bigger and better, as it were, every year. So thank you very much.
Thank you, Ralph, for that trip down memory lane. Lots of good memories. And about all the news as well, about the site. Do we have questions in the room? Right.
How big is that plane wave telescope?
I can't remember if it's a 19 or a 24 inch that they're talking about. Anyway, it's got, for that sky, it will do a good job. So, our telescope is a 16 incher, so it'll pick up a couple of magnitudes better.
Any other questions in the room? How about online?
We have a comment and a question online. A comment from Grace Horvatin, who says, the trees were so small then. As for a question, we have one from Atul Dave. Recently, I tried to visit the observatory, but I was informed that since I am visiting for the first time, I need to go through orientation. Now, you mentioned that there's an orientation coming. Will that be posted on the website? Will that be presented on a mailing list? How will that be communicated?
Okay,
and the second question is, what is the process to book?
Okay, thank you for the questions. As far as the orientation sessions are concerned, because of the nature of the plumbing system, among other things, and the fact that we do have an alarm system in place, we need to put you through a training session where you learn how to open the place without flooding the the house, burning the place down, or having the police come visiting because you tripped the alarm system. So the orientation is about a couple of hours, and we'll be offering it throughout the year, mostly on Saturdays, and those will be announced through the email forum for the members. Again, usage of the observatory is restricted to members of the Toronto Centre. And so it is important that your membership is paid up and that you attend this particular kind of session before you are allowed to use the place solo. Now, if there's a supervisor on site or there are other people who have experience with opening the site who are willing to let you do it, to attend, you can come to the site on a weekend when it is open and supervised, but otherwise it's restricted. Okay. As far as the booking fees are concerned, we do review that from time to time to make sure that we can meet our expenses. And currently, we do have a scheme of both daily visits with or without overnight accommodation, which can be either you camping, or we do have bed space for about 9 people, I think it is, inside the house, as on a first come, first served basis. And so you can book that if you wish online, and the fees are slightly different for those. The other thing, which is the really nice bargain, I think, is we offer a season pass. It runs with the financial year of the center, which is from October the 1st until the following September. And for a single fee, which currently is about $150 or thereabouts, you have unrestricted access to booking the site for as many nights as you like. It's just that we restrict it to no more than about 4 nights at a time, just to give people a fair chance at using the place. But we found over the years that this system works quite well. It's never been abused, and people generally have a good time being up there. Okay.
Will there be a second try with the Messier Marathon this year?
Okay, good question. We did try to organize a Messier Marathon this year. Unfortunately, the weather did not cooperate. The weekends that were optimal for it happened to be some of the few weekends when we actually had snow on the property and so on. Access wasn't good. The weather wasn't good anyway. We'll have to see. I think number one, we'll have to look at whether there's an optimal weekend in the fall that would allow us to do the marathon. The second thing will be whether people are interested in doing it, and we'll see. Yeah.
All right. Why don't we stop there? We're running a little bit late tonight. Thanks again, Ralph. To go to fun facts? We do. Okay, so we'll be right back as we set up for the announcements before we wrap it up.
Okay, so good evening, everyone, and thank you very much for joining us. My name is Tom Luton. I'm the president of the Toronto Centre of the RASC, and let's just get into our announcements then. So we've got 2 types of meetings. You've just been watching one of our recreational astronomy nights, and we're going to have one of our speaker nights coming up in 2 weeks, in which we're going to be having a member of the astronomical profession giving us a lecture. If you're joining us live on YouTube, please say hello in the chat. Please enter some questions for presenters. If you are a new member of the Toronto Centre, please introduce yourself. And if you're coming to us from far, far outside the Toronto area, please let us know where you're coming from. So our next speakers night is Wednesday, the 17th of April, 7:30 p.m. online only. Professor Paul Schultz of York University will be talking about fast radio bursts. What are they and where do they come from? You can join us live on YouTube. And then on Wednesday, May 1st, as Paul Markov said earlier, the Recreational Astronomy night, we'll be talking almost entirely about, we hope, all of the solar eclipse photos and details that we're going to be experiencing in the next week. Please drop Paul Markov a line at the email address shown here if you'd like to present. Now, we do have some solar observing coming up on Saturday, April the 6th at 10 a.m. to 12 p.m. RASC volunteers will be setting up filter telescopes outside the Science Center in the plaza area and giving folks a view of whatever the sun is doing that afternoon, or sorry, that morning. This is a weather-dependent event, so please check our website for the go, no-go call before heading out. And speaking of solar events, so as you've probably heard by now, there's a total solar eclipse happening next Monday. Just want to point out that there are no RASC Toronto events happening at the Ontario Science Centre on April the 8th. I received a few emails about this asking, and I want to make this very clear. Nothing is going on, even though there's an eclipse on our doorstep. And the reason why is because there's an eclipse on our doorstep. The simple fact of the matter is that the vast majority of the RASC Toronto Centre will be out of town. There's not going to be very few people around to handle any sort of events, with one exception, and I'll get to that in a little bit. But we're not going to be doing anything here at the Science Center, and the Science Center is not going to be doing anything with, because, well, we're not here. We provide the majority of the volunteers and the telescopes for outreach events. And as well, the Ontario Science Center is worried about the crowds. If you were here for 2017 with the partial solar eclipse, that was an amazing event with clear skies. There were a fair number of Toronto Centre members who could not get the week off to go down south into the States to see the total solar eclipse, but there were a few people like myself who could get the day off and handle outreach. The Science Center was expecting a crowd of about 500 people. Supposedly, they got 12,000. Supposedly, the police were about to shut the whole thing down. So, to this end, the Science Center is not going to be holding any astronomical events on Monday. Now, we do have free eclipse glasses available for anyone who wants them, who's here tonight. They're in the back. Please see me after the end of the announcements. Coming up, what else is going on? City Star Party, Bayview Village Park, the first clear night of the April 9th to the 11th, not the Wednesday. So really, that only because of the eclipse, it's only Tuesday the 9th or Thursday the 11th, 8 p.m. to 11 p.m., first clear night. And we're still waiting for details for restarting dark sky star parties. Again, please check our website for a go, no-go decision based on the weather. Millennium Square, public stargazing, the first event of the year, April 12th, 2024, 6 p.m. to 11 p.m. Please join us for an evening of free public stargazing along the North Shore of Lake Ontario, Millennium Square in Pickering. You can observe the moon and stars through our telescopes, take a look at the literature at our info booth and ask us some questions. Please bring your own telescope and we'll be happy to help set it up and point it at the moon. Just a reminder that it's usually colder by the lake, so dress accordingly. And again, check our website for a go, no-go decision based on the weather before heading to the square. Also, for the first time since COVID, the Ontario Science Centre will be hosting a star party. Saturday, April 20th, 8 p.m. to 11 p.m. Please check our website for a go, no-go decision based on the weather. And we're looking for volunteers, so I'm putting out the call now. Drop me a line to president@rascto.ca if you can help out. Coming up the DDO, it's going to be a busy month. Coming up on Friday, April 5th, 9 to 11 p.m. is DDO Astronomy Speakers Night, Solar Eclipse Special. Quentin Wayrick will be talking about what causes a solar eclipse. You can register online. And then on Saturday, April 6th, from noon to 2 p.m., DDO is Pre-Eclipse Sun Fun. Sunday, April 7th, from 12:30 to 1:30 p.m. is Pre-Eclipse Sunday Sun Gazing. And then Monday, April 8th, 2:30 to 4:30 p.m., there will be an eclipse program at the DDO. Full details and links can be found at rascto.ca. And then later on in the month, Friday, April 19th, 9 to 11 p.m. at the DDO is Astronomy Family Night. Registration fees and are as seen here, and the links are again at rascto.ca. Planetarium Day is April 20th from 1 to 2:30 p.m. And then wrapping up the month on Sunday, April the 28th, 12:30 to 1 p.m. is Sunday sun gazing. Note this is 2 weeks. This is more than 2 weeks after the eclipse. And as Ralph was saying earlier, the CAO is open. Just a reminder that there are still some CAO pandemic restrictions in place. The biggest one being that there's a maximum of 2 unrelated persons per bedroom who mutually agree to share said bedroom. Masking in the common areas is encouraged, but the preference of the people who are in attendance will be taken. And then please see the CAO bookings page for details on our website. Just a note, we're still looking always to fill some jobs on our job board. The Toronto Centre runs on volunteers. We're looking for a volunteer committee chair, marketing committee chair and committee members, and education and public outreach is always looking for additional presenters and telescope camera operators for virtual work. Reminder that in order to volunteer, you must first be a member of the Toronto Centre. Drop me a note if you'd like to volunteer. This is the part where I get to plug RASC membership. If you've been watching us and if you like what you see and if you want to join in, you can sign up online and you can renew your membership at secure.rasc.ca. Gift memberships are also available. Contact the national office and mempub at rasc.ca. Unfortunately, you'll note that this would normally be the part where I invite you to the meeting after the meeting. Unfortunately, the Granite has implemented winter hours, and the bar is closing in 11 minutes. So unfortunately, they'll be returning to summertime hours starting in May. So unfortunately, we're not going to be adjourning to the pub. For everyone else here and online, thank you very much for joining us and have a very pleasant evening. Please follow us on all the social media forum sites that we got listed here. If you like what you saw on YouTube, please like and subscribe, hit the notification bell. Be safe and keep looking up. Good night, everybody.